This is example 3 of the Solving Linear System with Matrices lab. We have the following system. Y plus z is equal to 4, 3x plus 6y minus 3z is equal to 3, and negative 2x minus 3y plus 3z is equal to 10. We want to solve this system using matrices. So first what we're going to do is write the augmented matrix from this. So we're going to write the coefficients of each variable into a matrix. So you have a x column, a y column, a z column, and a right-hand side column. I'll call it the equal column. So for our first equation, we don't have an x, so our coefficient for that x will be 0. Then we have a 1 in front of this y, so we have 1y. We have 1z. And on the right-hand side, we have 4. For the second equation, we have a 3, a 6, a negative 3, and a 3 for our y, z's, and equals. For the last one, we have negative 2 x's, we have negative 3 y's, we have positive 3 z's, and we have 10 on the right-hand side. So this is our augmented matrix. A lot of times they write a little dash in between the equal sign. So next what we need to do is get our calculators and input this matrix into it. So turning it on. We need to go to our matrix menu, so we're going to press second and this x to the negative 1 button. We see our names. We want to go to edit. We'll scroll down to the matrix of our choice that we want to edit. I chose to edit C. You can change the dimensions of the matrix. This is a 3 by 4 matrix. It's the rows times the columns. And then you go down here and you'll input all of the numbers we previously found. When you're done, you'll press second mode to get out of this menu. So now we're back to our normal menu. We need to go back into the matrix menu, so we press second x to the negative 1 again. And we're going to scroll over to math. We want to find the reduced row echelon form of this matrix, so we're going to scroll all the way down to RREF and press enter. Now we need to go back to our matrix menu to input the matrix that we're going to do that RREF on. So we go second x to the negative 1. Scroll down to the matrix that we previously edited. Mine was C. We have RREFC. We press enter one more time. It has given us our reduced row echelon form version of our matrix C. So I'm going to write that bigger so that we can see it. So from our calculator here, we have for our x, y, z, and equal column, we have a 1, a 0, a negative 3, a 0, a 0, 1, 1, 0, and a 0, 0, 0, 1. So this is the reduced row echelon form matrix that our calculator gave us. So what we need to do next is understand what this means. So I'm going to write it in equation format. So for this first equation, putting it back into equation form, we have 1x, so 1x, plus 0y minus 3z, which is what this is equal to 0. So that's what this first equation row tells us. So for our second row, we have 0x plus 1y plus 1z is equal to 0. So we have y plus z is equal to 0 from this row. And for our last row, we have 0x plus 0y plus 0z is equal to 1. So that's essentially saying that 0 is equal to 1. We notice that this right here is an impossible statement. It makes no sense, which means that we have no solutions because this makes 0 sense. So we have no solution for this system. We go back to our table, and if we have no solution, then the type of system is inconsistent. So this is an inconsistent system.